Okay, but now we are moving on to polygons. Let's review what's a polygon. A shape, essentially that's not rounded, right? We're more specifically going to talk about quadrilaterals this chapter, but today is all about their angles. Okay? So this first slide is not in your notes, but let's just fill out this chart together. So if we look at it, we start with the triangle. We all know what a triangle is. How many sides does a triangle have? 3. You can only draw one triangle within a triangle, so I'm going to put a 1 here. Okay. And how many degrees are in a triangle?
180.
180. Now, essentially, everything else is based off of this, off of triangles. Okay. So now if we go to a quadrilateral, how many sides are there?
4.
4. How many non-overlapping triangles can I draw in here?
2.
That's already done for us. There's 2, right? So now, can we figure out how many degrees are going to be in a quadrilateral?
Yes.
How many?
360.
Right? Because if I have 180 in this triangle plus another 180, I get 360. Okay, we're going to see a pattern here, hopefully. Pentagon has how many sides?
5.
How many triangles are in there?
3.
3. You guys know what this would be?
540.
540. What's an easy way to figure that out? 180 times 3. Okay, hexagon has how many sides? 6. How many triangles?
4. 7.
Okay, now here's my question. Can we figure out the generic formula for this? How many triangles would be in an n-sided figure? So let's think. 4-sided had 2 triangles. 5-sided had 3. And minus 2, perfect. Now what would this column be?
10 minus 2
Times 180, nice job. So that is our first formula. If we wanted to find the sum of the interior measures of a polygon, n minus 2 times 180. I'm going to go like this and write it down. N equals number of sides. So that's our first of 2 formulas today. N minus 2 times 180. So our first question says find the sum of the interior angles of a 15-gon. 15 just means 15, or 15-gon just means 15 sides. So what do we have to do? Yep, just plug into our formula. This is going to give us 13. What do we get, folks? Does that make sense? That one's pretty straightforward, right? Just plug in. Now let's try a little different example. How could we find x in this picture?
First, you just find the
You're right.
total interior angle
Yeah.
value, and then subtract all those added together from it.
Perfect. So first you have to find the total angle amount, right? So how many sides is that figure? 8, right? 8 if you count. So now let's plug into our formula. 8 minus 2 times 180. $10.80. And then Skylar said, add the ones we know and then subtract from 1080. And that will give us our missing one. So you guys take a moment, add up all those angles inside there, all 7 of them. You guys get 144? Ballpark, somewhere in there? Well, not ballpark, it should be 144. I hope. Okay. Okay, now, our next formula is if we just wanted to find one angle inside a regular polygon. So let's remind ourselves what a regular polygon is. All sides are equal, so therefore all angles are equal, if you want to fill that in. So the first part of the formula is actually the same. N minus 2 times 180. That would give you what all of them add up to be, but if I just wanted one, what do I have to do to that? You guys are great. Divide by the number of sides, because they all have to be the same. I'm going to take my total divided by however many sides there are. Now, this only works, maybe you guys want to highlight that, for regular polygons. Only works for regular polygons. So what is the measure of each interior angle of a regular pentagon? We're just plugging into that formula of 5, right? This pentagon has 5 sides. You guys get 108? Okay, perfect. That's what I got. 108 degrees. Okay, now we are asked, it says the measure of the interior angle of a regular polygon is 144. Can we find the number of sides? What do we have to do for that problem? So this time we were given the sides, right? And we found the angle. This time we were given the angle and we want to find the sides. So essentially we have to what? Work backwards, yeah, reverse the process. So start with your formula. N minus 2 times 180 all over n. And we know our angle has to equal what? 144. How do you undo divide by n? Multiply by n. That's how I'm going to get rid of this n down in the denominator. So those cancel. What should I do on that left side now? What's that? Well, you can divide, but then you're left with another fraction, so what's another thing you can do? You can do it that way, but I'm going to do it this way. When you multiply into both of them, what is that called? Distribute. So I'm going to get 180n minus 360. Bring my ends to the same side. What do we get? 36. Then divide out. N equals what, guys? 10. Does anyone know what a 10-sided figure is called? A decagon. I want you guys to write that down, just so you know. A decagon. How many years are in a decade? 10. That's an easy way to remember that. What about a 12-sided figure? Anyone know? Dodecagon. Essentially, anything after 12 sides, you just put the number and then gone. So 17 gone, 30 gone, and so on. Okay, now we're shifting gears to the outside angles, the exterior. And this one's easy. The sum of the exterior angles is always 360. There's no formula, you just need to remember that. They always add to 360. Always. No matter the shape, it's always 360. So, knowing that, how can we find the value of x here? What do we have to do? First, after those exterior angles. Yeah. They're all on the exterior part of that pentagon. But yeah, add up, set an equal to 360. What did you guys get for the value of x? 50. Okay, let's take a second and look at this picture up here. What do you guys notice about this exterior angle and this interior angle? They're linear pairs. What do they add to? And what about this guy and this guy? Same thing. And that one and that one? So maybe you should write that an exterior and an interior angle are a linear pair. That's good to know. Or they're supplementary. That would be a good thing to remember. an exterior and an interior angle are supplementary. In our last question here, our job is to find the interior and exterior angle of a regular hexagon. So is it more efficient to find the exterior or the interior angle first? Interior? I'm going to oppose you. I'm going to say exterior, because what do the exterior angles always have to add to? And do I know how many sides a hexagon has? What is it? So what do I have to do with 360 and 6? Just divide. So I would start with your exterior angle. I mean, really, there's more than one way to do this, but this is how I would do it. We should get. And then we just said the interior and exterior angle have to add to what? 180. So now we can just subtract. Like I said, more than one way to do it, but this is how I would do it to be efficient. And I'm all about efficiency. You guys okay with that? Okay, back in our book. Lots of time. Let's start the semester off good, everyone, not having anything out.